Very good morning. Today we will discuss the last class we discussed discrete Fourier transform for circular convolution. Uh, Today we extended the topic with respect to problematic point of view. Then we will clear that point. Last class we already seen that the problem. Just we have to be discussed within a clean manner with respect to understandable concept. And then first I will write it as a question. You have to keep in your mind and very understandable. For a they will give in the circular convolution. Find the circular convolution for given two sequences. The sequence one is 1 comma minus 1 comma minus 2 comma 3 comma minus 1. And then second sequence that is called as x2 of n, where x2 of n is equal to 1 comma 2 comma 3. So first we just move on to solving this problem. They will ask, first you have to be remember, they will ask concentric circular method, then you have to be solved by using the what we studied, concentric circle method. Obviously we solve this problem by using this method. Before solving these two convolutions, first you have to check the length of the strength of the two signals. The first signal strength is to be 5 and second signal strength is to be 3. So for that reason I will take it as a 1 comma 2 comma 3. Obviously the signal they will given, I can add extra two zeros to be make it as a both the signals, both the sequences. So what we have to do, both the sequences must be care about the equate. The first step, so we have to be so again we just like that we can write upon that this is the x1 of 0, x1 of 1, x1 of 2, x1 of 3, and then x1 of 4. And similarly x2 of 0, x2 of 1, x2 of 3, and then x2 of 4, and then x2 of, so 0 1 2 3 and 4. These are the sequence, we can know that. Now the point we can, I think not available, right? You can go for the next clue. You can take the so first we have to be calculate the, we can arrange the one circle. So first we arrange the one circle. In that circle I can name it as a, first we can consider x1 of n, and that x1 of n must be a anti-clockwise. First arrange the x1 of n in an anti-clockwise direction. So that you have to be remember, x1 of n is an anti-clockwise direction. So I just place it here. Here I can write it as a x1 of 0, then x2 of 0, then x2 of 1, then x2 of 2, then x2 of 3, and x2 of 4. These are the values I can write it as. I can, so it is the, so what is the x1? These are all of x1 of 0, x1 of 1, I, so just replace same thing we will write as. So first we can write it as a, where we can write it as a x1 of n. So x1 of 0, x1 of 1. So here we can place x1 of 2, x1 of 3, and x1 of 4. So just replace x1 of 1, 1, minus 1, minus 2, 3, and minus 1. Now the second thing is you have to replace the another circle. So just replace another circle, and where you can write x1 of 0, the same place you can write it as x2 of 0 initially. So x2 of 0, x2 of 1, x2 of 2, x2 of 3, and x2 of 4. Replace the values. So so x2, next what? x2 of n in a clockwise direction. So you can take x2 of 0 clockwise, means here it is the clockwise and it is anti-clock. x2 of 1, x2 of 2, x2 of 3, and x2 of 4. Just replace the values 1, 2, 3, 0, 0. And now the agenda is to be product of these two. Product of these two. So 1 into 1 and then sum. And similarly 2 into minus 1 plus, and then these two, 3 into 3 plus 0 into minus 2 plus minus 1 into 0. So 1 minus 2 plus 9 plus 0 plus 0. So simply 10 minus 2, the value is 8. This is what? Y of 0. For y of 0, you will be consider. Then calculate the y of 1. For y of 1, what I have to tell? For y of 1, you have to be anti-clockwise direction for x2 of 5, where you have to be replaced. Just you have to shifted all these directions in this manner. Means x2 of 0 shifted to here, x2 of 4 will be shifted to here, x2 of 3 will be shifted to here, and x2 of 2 replace. So likewise you have to be replace, right? Means what? Simply this is the x2 of 0, then it is what? x2 of 4, this is the x2 of 3, 2, 1, and replace the values. Values what? 1, 2, and values also 3, and it is 0, it is it is also 0. Right, everything is clear. Now again you have to be calculate for y1 of n. Same story, 2 into 1. So these two are to be multiplied. 2 into 1 plus 1 into minus 1 plus minus 2 into 0 plus 3 into 0 plus 3 into minus 1. So we have to 2 minus 1, 0, 0, and minus 3. 2 minus 4, you will get the minus 2. This is the y of 1. And similarly, if you want to calculate the y of 2, then simply Simply what? Simply here x1 of 0 initially we can write it as, now it's shifted, now it will be shifted. It is the x2 of 0, then it is the x2 of 4, x2 of 3, x2 of 2, and it is the x2 of 1. And again you have to replace the values with respect to there. 1, 0, 0, 2, and 3. Now we can calculate the y2 of 2. Simply product of these two. 3 into 1, 3, and minus 2 plus 0 plus 0. 3 minus 4, that value is to be minus 1 only. And then similarly, if you if you want to calculate y of 3, simply that will be shifted here, shifted here, it will be shifted, it will be shifted, it will be shifted. So likewise, you have to be calculate y of 3 and y of 4. So each and every part we can point out and you can take the notes. Okay. Thank you. We will see next class with the DFT and IDFT. Thank you.